Yesterday, we started discussing about what is Kubernetes, what is the architecture of Kubernetes. Today, we'll try to set up Kubernetes cluster. We are trying to set up self-managed Kubernetes cluster. So, I will try to set up a Kubernetes cluster using Kubedium, self-managed Kubernetes cluster. So let me create a servers quickly. So I am trying to use Ubuntu servers to set up Kubernetes. As we need to install Docker, so I'm not taking Red Hat servers. So I'm taking Ubuntu servers. To set up master machine minimum requirement, you should have a 4 GB RAM and 2 core processor. This is a minimum need for a master, 4 GB RAM and 2 core processor. For workers, we can practice with T2.micro, 1 GB and 1 core processor. And we need to open required ports. These are the ports which needs to be opened. So 6443 for API server. The API server will be running on 6443, and etcd will be running on 2379 and 2380. This port also needs to be opened. Kubelet 250, scheduler 10251, control manager 10252. These are the ports which are mandatory for control plane. For worker nodes 10250 kubelet. Kubelet will be running on 10250. These are the ports which we have to open, and along with this we have to open some ports based on the network which we are trying to deploy. So let me create a servers quickly. I am taking Ubuntu server, Ubuntu AMI. For master, we need T2.medium, so I am taking this. For now, I am opening all the traffic. For now, I am opening all the traffic. Okay. So these are the ports which we have to open. Along with this, we have to open few network ports. So for now, I am opening all the traffic here. So this, let me tag it as Kubernetes master. Now, let me create two more machines for workers. Worker purpose, I am going to create 2 more servers. So let me select this Ubuntu. For worker purpose, I am okay to use T2.micro for now. Here also I am opening all traffic for now. Just created one machine. Okay. So let me create another. I should have selected 2 instances. So I have total 3 machines created. One for master, 2 for workers. So now let's try to install the required softwares by connecting to these servers. So first let me connect to these 3 servers. Let me connect to these 3 servers. Similarly, let me SSH to other machines as well. Other machines. So I connected to all the 3 machines. Now we will install required softwares. So I have opened required ports. These are the softwares. These are the softwares or commands which we need to execute in common for both master machines and worker machines. This is common for both master machine and worker machine. If you see what are we doing here, we are updating the package manager, we are installing Docker, and we are disabling swap memory. So as per official Kubernetes documentation, it is recommended to disable the swap memory so that your kubelet will work properly. To work kubelet properly in your servers, you should disable the swap memory. So we are installing Docker, we are disabling the swap memory, and we are installing Kubernetes softwares. We are installing Kubernetes softwares by adding the Kubernetes package keys. So these are common in master as well as slaves. So let me do that. First, let me switch to root user. Guys, I'm parallelly executing in all the servers. You guys maybe execute one server after the other. If you miss some command, it may break. So I'm trying to parallelly execute in all the servers. So we are updating the package manager before installing Docker. I'm installing Docker. Docker is taking some time to install. Let's install Docker. So we are adding the current user to the Docker group. We will not execute Docker commands directly in Kubernetes. So this step is optional, but yeah, let's try to add current user to the Docker group. You can have it installed by adding in the user data, but you have to make sure all commands are not expected any human interaction. You can write a script. You can provide this as part of user data. Make sure you doesn't require any human interaction. So we are trying to install Docker. Somehow this machine is very slow. Docker is still getting installed here. So let's wait for some time. We'll continue once the Docker is installed in this machine. So we install Docker. Like let me add user to the group is this one-time activity. You are trying to setting up a cluster, like you are trying to set up the cluster, Kubernetes cluster. So is it every time you need to do? You are setting up your cluster, right? Do you need to set up every time? So this is just one-time activity. You are trying to set up a Kubernetes cluster. As of now, you don't have any Kubernetes cluster. I am trying to set up self-managed Kubernetes cluster. So we are trying to set up ourselves by installing required softwares. So now we have installed Docker. Now let's disable the swap memory. So in FS tab, we are permanently disabling the swap memory. Now here we are installing required softwares for Kubernetes. We are adding the package key, Kubernetes softwares apt key. So don't by heart installation commands. Don't by heart installation commands. No one can remember this curl, HTTPS, packages, cloud, right? So installation, they will just ask the components and what version of or what flavor of Kubernetes you used, whether you use self-managed Kubernetes cluster or managed Kubernetes cluster. So no one can remember these commands, right? Installation, as I told, installation is not DevOps. If you by heart and if you are good at setting up the softwares, you cannot become a DevOps engineer. Okay? Installation can be done in many ways. So we should know what is the purpose of the tool and how to use the tool. So you no need to worry about the installation. So but you should know what softwares are needs to be installed. So let's execute these commands. These three commands I'm executing together. I'm right, I am opening a file. This is the entry in that file, end of file. So let's quickly execute again, update. Now we are installing required softwares. What is mandatory, right? I'll come to this kubectl. We need kubelet and kubedium. Kubelet is, as we discussed, kubelet is kubelet is basically required in each and every machine. Kubedium is, with the help of Kubedium, we are trying to set up Kubernetes cluster. So these two are mandatory. And what is kubectl? As I discussed yesterday, so command line interface. So do we need to have a kubectl in each and every node? Do we need to have a kubectl in each and every node? Kubectl can be outside of your cluster also. kubectl can be outside of your cluster also. So this is your cluster. This is your cluster. You have a master, you have a workers, you have a master, you have a workers, and we have in master machine you will get an API server. You will get an API server. So kubectl, as of now, I am installing in this machine. kubectl I am installing in this machine, but kubectl can be part of any machine outside the cluster also. This kubectl can interact with API server. This kubectl can interact with API server. This kubectl you can install in any other server, and we can interact with API server. As of now, kubectl I am installing in the same machine. Instead of creating one more machine, in the master machine itself, I am installing kubectl, command line interface. So while installing in the master, I am trying to, not here, while installing in the master, this is what I am trying to use it as a master. I am installing kubectl also. While installing in these machines, I don't want kubectl. So just I am installing kubelet and kubedium, that's it. So I have done the required softwares. I am just starting the services, kubelet service. So in all these machines, just starting the kubelet service and enabling the kubelet service. So now the common softwares has been installed. As of now, we just have a normal 3 servers with required softwares. As of now, we just have a normal servers with required softwares. Now we have a Docker installed in these machines, and we have a Kubernetes softwares like kubelet installed. So now how to set up the cluster? In one of the machine, which I want to make it as a master, we will execute this command, kubedium init. Only in the master, we are trying to initialize the Kubernetes cluster by executing kubedium init. With the help of kubedium, we are trying to set up the cluster. So only in the master, these commands we are trying to execute only in the master. So multi-master, it is completely different setup. It will take minimum 2 hours. I will share the document. Multi-master, It is not the way we are trying to set up in the Docker Swarm. It doesn't give basically master token, right? So in case of Kubernetes, multi-master setup requires lot of step. Minimum it requires at least 2 hours to set up self-managed multi-master. So I will share the document, right? You can go through and set up if required. So now I am trying to, in this machine, I am trying to execute Kubernetes init. So it will initialize the master. This, this is trying to set up this machine as a master. The moment I execute this Kubernetes init, what is happening here? In this machine, I executed Kubernetes init. What is happening here, right? So the master components. What are the control plane components? What are the control plane components? So the control plane components. API server, server, scheduler, etcd, and control managers. These are the control plane components. So here also for high availability, we will always go with 3 numbers, odd numbers in Kubernetes also. If you want to have high availability, like minimum we will go with 3 servers. Okay, but the setting of the cluster is different. You cannot, it will not give a manager token. You need to create a 3 replicas of API servers, 3 replicas of etcd, 3 replicas of control managers and schedulers. I mean to say 3 master machines. The setup is not the same as what we do in a Docker Swarm. Okay, I'll share the document to set up for multi-master. Self-managed. If you go for a cloud, you can simply say I need 3 masters. So they will take care, high availability. Now, the master has been initialized. Your Kubernetes control plane is initialized successfully. Now these are ready. API server, scheduler, etcd and control manager is ready. Your control plane has been initialized successfully. To start using your cluster, you need to run the following as a regular user. Why this is required? What we are trying to do with this? Why these commands are required? To start using your cluster, you need to run the following as a regular user, not as a root user. What we are trying to do this one? So how can I interact with API server now? How can I interact with API server? With the help of kubectl. So we already installed kubectl. For kubectl, what is required? Kubectl is a one command line interface, right? What is required? It requires your Kubernetes cluster information, where it is running, right? What is the username, root username to connect. Without having any information, will kubectl will be able to communicate with API server? API server is also running on some IP, some port. It requires that information, right? If you see what we are trying to do, we are creating one home directory as a regular user. Don't execute these commands as a root user. As a regular user, we are creating one folder called .cube, and we are trying to create one file under .cube, cube config file from this. What is this? What is there in this? What is this? What is this IP? And what is this port? What is this IP? It's not an UI, guys. What is this IP? This is your master machine IP. And what is this 6443? As per our documentation, what is running on 6443? API server port. And it has has a which user you are trying to connect with the help of kubectl, your Kubernetes cluster information. This file has the Kubernetes cluster information. So this is required for your kubectl to connect. This information is required for your kubectl to connect. So what they are saying, as a regular user, create this, and then you can execute. So let me switch to regular user. Now I came out of root user. I am in a normal user. Now if I execute this kubectl commands, do you see, is it working? Kubectl get nodes or kubectl get pods. What is required for your kubectl? What is required for your kubectl? You need this information. You need this information. So what is required? Where should I have that file? Kube config file. In this user home directory, I need one folder like this. Now within that folder, I am creating a kube config file with the help of this. In the master machine, when I initiated a Kubernetes cluster, this file got generated. This has the cluster information. Copied and then change the ownership. Change the ownership. Now, when I execute this kubectl commands, it is trying to talk to the API server. This kubectl is using this information. In this current user home directory, we have a kube config file. It is using that information to communicate with API server. So now, as of now, how many nodes I have in this cluster? Only one node. And what is the role of that node? Master. And if you see why it is not ready, still it is not ready. Why it is not ready? If you observe, guys, if you see, I will come to this what is namespace, and all. If you see, in this namespace, cube system namespace, this control plane API server is running also as a pod, API server also running as a pod, control manager also running as a pod, kube proxy also running as a pod, scheduler also running as a pod. These pods are ready and this pod is not ready. DNS pod. What is DNS, guys? What is DNS? Domain name server. So basically this is cluster DNS. Within the Kubernetes cluster, we have a DNS solution. So let's assume you have multiple applications deployed. If one application has to communicate with another application, you no need to depend on the IP address of your pods. You no need to depend on the IP address of your pods. There will be an internal DNS. So you can create a service and you can use a service name. So it will resolve the IP address if you are using service name. Within the cluster, there will be a DNS for a communication. And this is not ready. This is in pending state. Why it is pending? You need a network. You need to apply a network for this Kubernetes cluster. You need to apply a network for this Kubernetes cluster. So this is not at all ready as of now. Why it is not ready? Because we need a network. Kubernetes networks. Kubernetes network. Basically container network. You need a container networking. So there are a lot of container networks for your Kubernetes cluster. Kubernetes has set a standards. Kubernetes has a set of standards, CNI, container networking interface. Kubernetes has set some standards for a networking purpose, CNI, container networking interface. So they have set the standards, and there are a lot of providers who implemented the network solutions for Kubernetes. CNI, Kubernetes CNI. Container networking interface is defined with some standards. Interface, right? You know, like programmatic language interface is defined with some standards. For Kubernetes networking. So there are lot of providers who implemented network solutions for Kubernetes with by following or implementing this CNI. So there are lot of network providers like ViewNet, Flannel, Calico. Basically, these are kind of overlay networks. In Docker also we discussed what is overlay network, multi-host networking. Why it is required? Why this network plugins needs to be installed? Why it is required? What is the responsibility of these networks? Who will allocate the IP address? Who will allocate the IP address for your containers or pods? Basically here, DNS will not allocate. Nowhere DNS will allocate the IP address. DNS will just have a mapping of your IP with name. In Kubernetes, again, who will take that responsibility? This network plugins, these networks. So DNS nowhere it will allocate the IP Prasanna. DNS will just hold the mapping of your IP with the name. So these are the network plugins. Like in Docker, we have a overlay driver, right? Similarly, we have network plugins like ViewNet, Flannel, Calico. So CNI, as I told, container networking interface is a specification designed for a Kubernetes networking. So there are lot of providers who follow, who supported the networking solution by following this. So there are lot of like Calico, Flannel, there are lot of providers. If you see, so we have these are the networking solutions like we have a Calico, we have a Flannel, overlay network, and we have a ViewNet. So any one of the solution we have to host. Calico is a network and network policy provider, right, for a Kubernetes. So whatever add-on you want to use out of this. So that network is not installed as of now. The network plugin is not installed as of now. That's why your core DNS is not coming up because there is no network add-on in this cluster. So for now, what we are trying to do, I am trying to apply a network. What network plugin I am using? What type of network plugin I am trying to use? If you see, I am using ViewNet. So we are trying to deploy a network in this cluster. So let me deploy by executing this command. Now network related parts also now ready. The network related parts also now ready. This will take the responsibility for allocating IP address for your pods and for a communication. This will allocate IP address for your pods, and it will responsible for communication. If I go for a AWS, there will be a, if I go for a EKS, there will be a EKS related add-on, right? So this is responsible for allocating a IP address for your pods and for communication between your pods. It is kind of overlay network for your Kubernetes. Now, if you see, my network pod is running. Now, do you see, once the network pod is ready, once the network driver, network plugins are ready, do you see, is it running now? The core DNS. So now my master machine is ready. My master machine is completely ready. Now, how can I add the workers? How can I add the workers? So I will get a token here, only worker token concept, guys. There is no master token. So this you are getting, because I added a Ubuntu user to the Docker group, but the session is not refreshed. If I exit, let me come again into this one. So I will not get that first error. So now I got the token. This is the token. Guys, you no need to walk all these steps, right? They will ask only the architecture. What is there in the master? What is there in the worker? And they will ask, what Kubernetes CNI provider you are using. What is Kubernetes CNI? Container networking interface is a specification set by the Kubernetes, and there are a lot of providers who providing a networking solution, and they are asking like what is Calico, which which CNI provider you are using. So you no need to remember all these steps, but the components are important. So now we got the token. This is my token. Guys, in the Kubernetes 1.2.0, this warning will be removed. Kubernetes 1.2.0, this warning will be removed. As of now, we are getting one warning. So in Kubernetes 1.20, this warning will be removed. So there is an issue in this version. We are just getting some warning. So ignore this warning. And this is your token. So the token contains your API server information. So where should I execute this token? So that it will join the cluster in the worker machines. Execute with sudo or execute as a root user. Now the worker is trying to join with your master. Now, these are yet to be ready. It will be ready after some time. This yet to be ready after some time. So what is the current version which we are using? We install latest version. What is the current version of Kubernetes if you see? 1.19.4, 1.19. Now my cluster is ready. My cluster is ready. I have one master and two workers. Guys, kubectl, again I am explaining. Kubectl can be installed in any machine. Suppose I want, this is my Jenkins server. Let's assume I want my Jenkins to connect to the Kubernetes and deploy. I no need to SSH to this server from my Jenkins and execute kubectl commands. What can I do? In this Jenkins server, I can install kubectl and I can configure that kubeconfig file. If I have a kubectl installed, if I have a kubeconfig, from this machine also I can directly talk to the API server. From here itself I can execute kubectl commands. So I just need a kubectl and kubeconfig to communicate with API server. As of now, I have installed kubectl in the same machine, master machine. So let me show you. If you want to connect to the Kubernetes cluster from a different machine, let me create some server. I can create any type of server. I can create Red Hat server also. I'm just saying Kubernetes client. It can be like any machine. This can be a Jenkins server, your CI/CD server. Right? So from here also, I can connect to that Kubernetes cluster. For that one, what software is required in that machine? If I want to connect to the Kubernetes cluster using CLI, so still that machine is not completely ready. Let's wait for some time. Now, this is one normal machine. If I want to connect to this Kubernetes cluster for deploying something, in this machine, I just need a kubectl software and that kubeconfig information. So here, I'm going to install only kubectl. Install kubectl. So I'm just going to install only kubectl in that machine. Linux, you can follow these steps. any Linux. So I'm installing. I downloaded kubectl software, gave executable permissions, move to the bin. Now I have a kubectl installed. Kubectl installed. But will I able to connect? Will I able to get the details? Will I able to communicate with? So what is missing here? Config. The kube config. The kube config is missing. Now let me create a folder, one directory dot cube. Within this directory, if I have that config file, I will take from here. I will take from here, from my Kubernetes. I have my kube config file. Now will I able to communicate? Do you see? Now, is this my master? Is this my master or worker? It's just a normal client, right? I can communicate. If required, I can deploy from here itself. And this machine and my Kubernetes master is in same network, so it is able to communicate. If you see the kube config, in kube config, what is the IP? Is it having a public IP or private IP? In the kube config, private IP, and this server and my Kubernetes server is also in same network, so it is able to communicate on a private IP. Okay. So this is how you can set up the client. This is how you can set up the client. Now my Kubernetes cluster is ready. What next? What do we do, guys, in our in your Kubernetes cluster once the cluster is ready? This is for a deployment purpose. This is for a deployment purpose, right? What are we trying to do here? We are trying to deploy our applications. We are trying to deploy our applications. We are trying to deploy our applications as a containers in a Kubernetes cluster. So before deploying a container, first we have to understand the Kubernetes concepts. Kubernetes concepts or Kubernetes objects. I can call it as a Kubernetes objects. In Docker, also we have some kind of objects, right? We created image, container, network, right? Value, Docker service, Docker stack. These are like a Docker objects which we created. Now in Kubernetes also we have some objects. I can call it as an object. Pods or pod, replication controller, replica set, daemon set, deployment, right? Stateful set, service. Like these are kind of a objects. In Kubernetes, these are kind of a objects. And there is a concept called namespaces. Namespace in Kubernetes. So if I want to deploy my application in a Kubernetes, can I create a container directly? Right? So Kubernetes concepts are little different. You are creating a containers, but the containers are wrapped under one Kubernetes object called pod. So you are deploying your application as a container, but that container is wrapped under pod. So first we will understand what is pod, then we will deploy the application. So Kubernetes objects, we call this one as a Kubernetes objects or workloads, right? If I want to deploy some application, I have to create some objects. I need to create some objects to deploy my application in a Kubernetes cluster. I have to create some objects, Kubernetes objects. Like in the Docker, container is also kind of an object. Service is also kind of an object. Stack is also kind of an object in Docker Swarm. Here, these are the like Kubernetes objects or workloads. So Kubernetes objects are persistent entities in your Kubernetes system. Persistent entities. What is the meaning of persistent? If I create an, this object, Kubernetes will try to make sure you have that object in that cluster. Kubernetes use these entities to represent the state of the cluster. So once you create this object, Kubernetes system will make sure this objects available in your cluster. So to work with these Kubernetes objects, if you want to create a pod, if I want to create a deployment, or if I want to create any object, whether to create, modify or delete, we have to use the Kubernetes API. So how can I communicate with Kubernetes API server, and how can I ask, can you create a pod? Can you create a deployment? Can you create a service? How can we communicate with API server to create these objects? With the help of, how can we communicate with the API server to create, update, delete these objects? These objects is nothing but our application related stuff. So we can use kubectl, CLI. So if I want to deploy something in Kubernetes cluster, I have to create these objects. If I have to deploy some application, I have to create this object. These objects basically will represent containers. It will represent basically our application. This is for a communication. Service is for a communication. We will come to that in detail. Before I create a pod or before I create a service, first let's try to understand the namespace. Kubernetes namespace. If you see kubectl get namespaces, I have a nodes. Nodes are nothing but your machines, your physical machines or virtual machines. Within this cluster, I have a namespace. I can create a namespace. If you see, these are the namespaces as of now I have. These are the namespaces as of now I have. So what is namespace? What is the purpose of namespace, right? You can think namespace as a cluster inside the cluster. You can think namespace as a cluster inside the cluster. So like I have a multiple projects within the same client. For the same client, I have a multiple projects. I want to isolate those applications within this cluster. I want to isolate those applications within the cluster. So what can I do? I can deploy those applications in a different namespace within the same cluster. Guys, it's like it's like if you are from a development background, it is like a packages. It's like a package. If you are from development background, right? Like Java. In Java, there is a concept called package. So what is the purpose of package in Java? Basically, we are going to keep all the related files in one package. So similarly here, Kubernetes namespace is nothing but a logical concept. We are trying to isolate the applications or the Kubernetes objects using namespaces. If you see, these are the default namespaces as of now. -n represents namespace. What is running in this namespace? Already there are some Kubernetes objects, like you can see there are some pods, there are some service, there is some daemon set, there is some deployment, there is some replica set. Already some Kubernetes objects are created in this namespace. These Kubernetes objects are for what? Is it our application related Kubernetes objects or workloads? Is these pods are our application related pods? So these are basically system, your Kubernetes control plane related, Kubernetes control plane related objects, Kubernetes objects. So they are logically isolating these applications in the namespaces. So namespace is like a kind of a folder. You can think of like a folder where you can place something, right? So Kubernetes namespace is like a cluster, virtual cluster inside your Kubernetes cluster. You can have multiple namespaces. You can create multiple namespaces. They are logically isolated from each other. So what is the advantage, or what is the purpose of namespace, right? So these namespaces will help us and our teams to organize our applications. To organize our applications. So by default, we have these namespaces. If you see Kube system is for all the things related to Kubernetes system. Any deployments to this namespace will cause some problem. So is it recommended to deploy our pods, our Kubernetes application pods in this namespace? So this Kube system namespace is for the Kubernetes related pods are running. Is it recommended to deploy our applications in this namespace? It is basically, this is for only Kubernetes purpose. So we can use namespaces for isolation, purpose. So suppose I have two projects within the same client. Let me take this scenario. I have a project A and project B. For the same client, I have a project A and project B. How can I isolate these project related application, the Kubernetes pods services in Kubernetes cluster? What can I do? I can create a namespaces. This project I can run in one namespace. This project I can run in another namespace. So we can use namespaces for an isolation purpose. Like, as I told, split many users project into a separate namespaces. So while creating our applications, you can mention under which namespace you have to create these objects. While creating these Kubernetes objects, we can define under which namespace these Kubernetes objects needs to be created. If I don't mention any namespace, under which namespace these objects will be created? If I don't mention any namespace while creating the pods or controllers or service, the Kubernetes objects, if I don't mention, under which namespace it will create? By default, there is a namespace called default. There is a namespace called default. Under this default namespace, it will be created. And I can apply the security. And I can apply the security at namespace level, guys. What does it mean, right? I have two developers. Balaji and Mithun. So Balaji is working on this project. Mithun is working on this project. Both the projects I can deploy in a same Kubernetes cluster. But if I deploy in a two separate namespaces, what can I do? I can apply a security saying that Balaji cannot do anything in this namespace. And Mithun cannot create or update anything in this namespace. Namespaces we are using in a Kubernetes cluster for an isolation purpose. All the related applications you can deploy in one namespace. which can be isolated from another namespace within the same cluster. We have a namespaces. If required, I can create a namespace. How can I create a namespace? kubectl create namespace or ns. You can use namespace or ns, short name. Something like this. Test, one namespace. Now, I got a namespace created. Now I can deploy the application, some application in this namespace. It's a logical grouping of your Kubernetes workloads. Now, how can I deploy the application? Guys, Kubernetes is only related to deployment. It is not build, right? In Kubernetes, I am trying to deploy Docker container. So if you want to deploy something in Kubernetes, Docker related containers, first you should have an image. Kubernetes is only for a deployment purpose. You should already have an image. So once I have an image, how can I deploy that application in a Kubernetes cluster? So let's start with basics, the small object. First, we will understand what is pod, how to create a pod. Then we will discuss the other objects. So pod is the smallest building block. Pod is the smallest building block or basic unit of scheduling in a Kubernetes. Pod is the smallest building block or basic unit of scheduling in a Kubernetes. In Kubernetes, pod represents the running process. In Kubernetes, pod represents the running process. Guys, in Docker, what is the smallest one which we can deploy? Which one will represent the running process in Docker? In Docker, container is the smallest one which we can deploy. Container represents the running process. Whereas in Kubernetes, pod is the smallest one which we can deploy. In Kubernetes cluster, pod represents the running process. What is there in the pod? What do we have inside the pod? Inside pod, you can have one or more containers. In Kubernetes, you cannot directly deploy the containers. In Kubernetes, you will not deploy the containers directly. You are going to deploy the pod. Pod will have a one or more containers. So those containers will share unique IP address, storage, and network. Suppose I create one pod. This is pod in Kubernetes. We are going to create a pods. I created one pod. I can create single container pods. Single container pods, something like this. Or I can create multi-container pods. What is multi-container? Multiple containers in the same pod. So Inside the pod, you can have one or more containers. These containers will share a unique network IP address, storage, and other specifications. So this pod will have a IP address. This pod will have a IP address. Now these two containers will share same network. This container and this container will both are running in a same pod. If they are running in a same pod, they will have a same IP address, same storage, and any other specifications. I can have a single container pod or I can have a multi-container pods. Now this is also one question, guys. They are asking how one container can communicate with other container if they are in the same pod. Within the pod, how they can communicate with each other. They will have a same IP. They will have a same IP, right? They can communicate using local host. Now pod has a IP. Inside the pod, if there are two containers, they can communicate with each other using local host and the port. So inside the pod, if you have a two containers, how this container can communicate with this container? Using local host itself, because both the containers are running in a same pod. So these will have a same IP. They can communicate with each other using local host. They no need to depend on any IP address. This guy can communicate with this guy using local host. Now, can I able to do something like this? Within a single pod, can I have a two containers with same port, container port? Is it possible? Within a same pod, within a same pod, because both are running in a same pod. Pod will have a network. Pod will have a IP. So you cannot able to run two containers in a same pod with same port. So if you see inside pod, you can have one or more containers. Those containers will share same network, storage, and any other specification. So you cannot have a two pods, one pod with multiple containers and containers of same port. Pod is basically group of one or more containers which will be running on some node. Pod is nothing but a group of one or more containers which will be running on the node. So pods will abstract the network and storage away from the underlying container. Now pod is abstracting the network and storage away from the underlying containers. Now pod will have a IPs. Pod will have a network. So now we have to create a pod. So how can I create a pod? What are the ways? Declarative, and imperative. So kubectl, I can use something like this, kubectl run. This is imperative commands, right? So we will not use this approach. We are going to use declarative approach. What is declarative? We are going to define the information in the form of Kubernetes manifest. We are going to define the Kubernetes objects information in the form of manifest. Kubernetes manifest files. So if I want to create some pod, right, we are not going to use these commands, imperative commands like docker run, right, image, port, all those things, right? This is command, imperative. So we are going to use declarative approach in the form of YML. If I want to create any Kubernetes object, I can do using commands also, or I can define this information in the form of manifest and I can apply. So now, first let's get started with pod. Now I want to create a pod. So pod will have one or more containers. So how to define that information? Basically in the form of YML. Something like this. There will be a 4 important tags in your Kubernetes manifest. So API version, kind, metadata, and spec. API version, kind, metadata, and spec. So for each and every Kubernetes object, there is a API version defined. If you see, I have given one diagram, guys, here. API version and kind. Now I am just starting with pod. I am trying to create a pod. So what is the API version for a pod? V1. So API version V1. Kind, what kind of Kubernetes object you want to create? What kind of Kubernetes object you want to create? For now, what I want to create? I want to create a pod. Metadata. Name. Your pod name. Let me deploy this application. Java Web App pod. Labels. I can give a labels. I am trying to create a pod name, and labels for the pod. I can give any label, key and value. Now what pod will have? Pod will have containers. Pod will have containers. Where can I define my container information? Here. Containers, name of the container. Something like this. Image. From which image you want to create? Ports. Your container port. What is the port of this one? 8080. This is pod manifest. I can say pod manifest. Suppose if I apply this pod manifest, how many containers will be created within this pod? 1. If I want to have a multi-container, other container, one more container, this section will be repeated. If I want to create another container, but we cannot create container with same port. I'll come to that tomorrow. Different port number and different application altogether, right? So in real time, most of the cases you will go with single container pods. So tomorrow we will discuss what is multi-container pod, in which scenario we will go for a multi-container pod, right? So we will discuss that tomorrow. For now, let me create a container, single container pod. So this is my YML. My pod manifest. Now, let me fix the indentation. And I have not mentioned the namespace. Under which namespace this pod will be created, guys? Under which namespace this pod will be created? I have not mentioned the namespace. Under which namespace it has to be created? If required, I can mention the namespace here. I can mention the namespace here. Namespace test. Now, if I apply, under which namespace this pod will be created? Test. So here I can mention a namespace name so that this object will be created in that namespace. Now first let me deploy default namespace. Now kubectl apply -f your file name, your manifest name, -dry run. If you want to validate, you can do the dry run. Something like this. It will just do the dry run. It will validate. If you have some mistakes, suppose let me do some mistake. I'm not using proper options. Now do you see? Right? It's saying this error, right? So let me fix that. So let me apply. Tomorrow I will explain what is difference between apply and create. So first let me apply. Now pod is created. kubectl get pods. Guys, this is by default. This is pointing to the default namespace. When I execute kubectl get pods, it is pointing to the default namespace. So I have a pod. I have a pod. What is this? One by one. What is this one by one? It is container. Within that pod, we have a one container. Guys, here, if I want to replicate, what I need to replicate? Do I need to replicate the containers or do I need to replicate the pods in Kubernetes if I should have a more number of containers for my application? What I need to replicate? I have to replicate the pods. Containers is inside your pod. I have to replicate my pods. I need to replicate. I need to scale up, scale down my pods. Guys, in Kubernetes, we are not directly handling with containers. Containers are wrapped under pods. So we just deploy the pod. We just deploy the pod. So how can we access the pod? What is the problem with pod? We'll continue tomorrow, guys. We just created a pod. How to access the pod inside the cluster and how to access the pod outside the cluster. We'll continue tomorrow. Tomorrow we'll try to understand about this service. We have a pod. If I want to access the pod within the cluster or outside the cluster, we need to create a service. Tomorrow we will discuss what is service, how to create a service, right? And what is the problem with pod, why we have these controllers. We'll continue tomorrow, guys. Today I just set up the Kubernetes cluster and I just discussed about namespace and pod. We just created a pod. So tomorrow we'll continue further topics.